What does it really mean for an AI to think? Today, we're diving deep into the end of coding. Manual code generation is no longer the primary path to software. Foundation models now reason across entire code bases, APIs, and infrastructure to generate systems directly from intent. This is not Copilot assistance. It removes the translation intermediary between thought and execution. The strategic shift, who can build, how fast, and at what marginal cost, all transform. Model capability, tool integration, and enterprise readiness converge. The next era of software creation has begun. The era of intent-driven development is here. But here's where it gets interesting. The translation bottleneck. Current software development is a manual, multi-step translation from human intent to machine instructions. Each handoff, requirements design, code, test, deploy, introduces latency, misinterpretation, and defects. Coding is lossy encoding of intent into syntax. This bottleneck limits iteration speed, system complexity, and who can participate. IDEs and low-code platforms abstract syntax but not semantics. Low-code rearranges syntax. The translation problem persists. Throughput is constrained by human translation bandwidth, the root inefficiency in software engineering. So what's the real problem? Let's talk about the complexity ceiling. Modern systems, microservices, distributed state, security policies, compliance, multi-cloud have exponentially growing surface area. Human cognitive capacity cannot hold the full dependency graph. Handwritten code leads to fragility, merge conflicts, and unmaintainable legacy. Maintenance burden outpaces feature delivery. New abstractions add integration overhead without reducing underlying complexity. Existing methods, microservices, serverless IAC, shift complexity, don't eliminate it. Manual orchestration hits a viability ceiling. The gap between system scale and human capability widens daily. This raises a critical question. Root cause: cognitive bandwidth mismatch. Human working memory is limited to 4 chunks. A modern codebase has millions of tokens. Intent-to-code translation depends on mental models that degrade with scale. Errors correlate directly with system complexity, not developer skill. The limitation is biological, not tooling. Existing approaches, abstraction, code generation, only raise the level of syntax, not semantic understanding. We design systems in a space we cannot fully comprehend. Diminishing returns on engineering investments. No amount of process fixes the biological constraint. Now let's zoom in on the breakthrough: semantic compilation. Recent AI models achieve deep semantic understanding of intent, code semantics, and system behavior. They decompose high-level goals into executable plans, generate verified code, and orchestrate infrastructure. This is not pattern matching. It's reasoning over constraints, trade-offs, and correctness. The model becomes a compiler from natural language and constraints to running software. Verification is built in, tests, formal proofs, simulations generated alongside code. Unlocks software creation from cognitive limits. The shift is as profound as the introduction of high-level languages. Here's something most people overlook: new system architecture. The architecture for intent-driven software creation is layered with AI at every stage: intent specification, natural language, sketches, formal constraints, examples, reasoning and planning, decompose intent, resolve ambiguities, select optimal architecture, synthesis and assembly, parallel agents generate review, compose modules with guaranteed interfaces. Verification and safety, auto-generated tests, formal proofs, compliance checks, runtime adaptation, observability signals feedback to regenerate, self-heal, optimize. Human roles shift to curator, governor, domain expert. enables continuous, verifiable, autonomous evolution. Think about this for a second. Core components. The system comprises 6 integrated subsystems: intent interface, multimodal canvas, text, voice, diagrams, constraints for capturing desired outcomes, agentic orchestrator, dynamic assignment of specialized reasoning, coding, and review agents. Generative pipeline outputs source, infra as code, tests, docs, and deployment manifests. Verification mesh layered safety, static analysis, simulation, formal proof, policy compliance. Feedback engine runtime telemetry drives auto fine-tuning, self-healing, and optimization. Knowledge graph evolving semantic model of system intent, decisions, and dependencies. Together they form a closed loop. Intent generation verification improvement. And this is where things get complex. Workflow transformation. Traditional pipeline. Requirements design, code review, test, deploy, monitor. Linear, slow. New pipeline. Declare intent AI negotiates requirements, constraints, trade-offs, generates full system continuous verification, autonomous deployment, self-adapting runtime. Human intervention moves from implementation to outcome definition and exception handling. Iterations become real-time conversations. Testing, security, compliance are embedded, not gate phases. Feedback loops refine future generations. Cycle time compresses from weeks to minutes. The developer role dissolves into intent engineering. But here's where it gets interesting: economic impact. Development cost per feature drops by orders of magnitude. Time to market collapses. What took quarters now takes hours. Defect rates decline through built-in formal verification and simulation. The marginal cost of additional functionality approaches zero. Software creation democratizes. Domain experts directly express intent without engineering intermediaries. The software industry reorients from construction to curation and governance. VC shifts from funding teams to funding intent clarity. ROI moves from labor arbitrage to precision of intent. So what's the real problem? Let's talk about organizational transformation. Existing roles evolve: developer, system architect, directing AI agents, and defining system-wide constraints. QA verification strategist, designing safety properties and oversight frameworks. Operations resilience designer, specifying SLOs, failover policies, cost boundaries. Product manager, intent engineer, formally specifying outcomes and acceptance criteria. New roles: AI ethicist, alignment, feedback analyst, production signals, knowledge curator, system memory. Teams become small, high-leverage orchestrators. Headcount doesn't scale with complexity. Outcome ownership does. Culture, from lines of code to clarity of intent. This raises a critical question: future trajectory. Self-improving loops: AI analyzes runtime behavior, regenerates optimized code, restructures architecture. New programming paradigms emerge from model-native design patterns beyond human syntax constraints. Software becomes a living knowledge graph, perpetually coherent and up-to-date. Boundaries between application, database, and infrastructure dissolve into a unified intent graph. AI discovers novel algorithms and end system designs beyond human imagination. Software becomes real-time adaptive utility. The question shifts from how to build to what should be true. We enter the era of ambient software. Now, let's zoom in on the end of coding, the beginning of creation. When coding disappears, software development becomes indistinguishable from domain thinking. Doctors design clinical systems. Logistics experts orchestrate supply chains. Artists generate interactive experiences. The only prerequisite is precise intent. Software is no longer constructed. It is cultivated and evolved. We move from tools that execute commands to partners that interpret goals. The end of coding ends its priesthood. All can speak systems into existence. Build what you mean. This is not automation. It is liberation.